In this demonstration, we will see what happens in the background when a user requests to provision a Kubernetes cluster in VMware Cloud Director using Container Service Extension. In this setup, we have Container Service Extension 4.0 server, which is running in the provider managed organization. Kubernetes cluster will be deployed in tenant A organization and pre-configured VMware NSX Advanced Load Balancer. When a tenant user initiates a request to provision a Kubernetes cluster using Kubernetes Container Cluster UI plugin, Container Service Extension Server updates the cluster specification in VMware Cloud Director with the desired state, and the RD specification gets created. Container Service Extension Server, which is running in a provider managed organization, continuously monitor for RD specification. Once a Container Service Extension Server identifies cluster creation request, it creates a VApp with the same name defined during the cluster creation wizard. Container Service Extension Server creates an ephemeral virtual machine with a cloud init script, which perform tasks such as install kind-based bootstrap cluster, install cluster API, and cap VCD in bootstrap cluster. Now, Cloud Init script makes this local cluster a management cluster by initializing cluster API. Once a bootstrap cluster is configured completely, the specification that tenant users have updated during cluster creation wizard is applied to bootstrap cluster. And as a result, workload cluster is created. Now, Cloud Init script install component such as cap VCD, which is responsible for cluster creation and management. Certain cap VCD records are also moved from bootstrap cluster to workload cluster at this point in time. And other components such as cloud provider interface, cloud storage interface, CNI, and RD projector. Once workload cluster comes to a stable state, chain between bootstrap cluster and the workload cluster is broken. Now the workload cluster becomes a self-managing cluster, and finally, ephemeral virtual machine is shut down and deleted. Henceforth, any subsequent request like resize and upgrade of the workload cluster from a tenant user will be managed by cluster itself without Container Service Extension Server intervention. That concludes Kubernetes cluster creation workflow demonstration. We hope you found this information helpful and informative. Thank you for watching.